Hello friend, how I treat the data of pi FCCS we record on microscope. I will go step by step. So first of all, we collect data and we make one folder. So in this folder, as you all know, we make one folder for alignment, an image. So we collect some image here, how, and then you know how we focus on that. I will show you this in another video, but today I will show you how we use all the MATLAB script to get the parameter we wanted to know. Okay, so first you need MATLAB. As you know, I will open MATLAB here. It may take some time. Okay, so my MATLAB is open now. So I'll go to the folder which I want to. So because I have used already this one, so it's already open, and I have a couple of script open here. One is PTU2mat, and another one is PTUM2fit, and then three different for the H core, G core, H core, and X core. I will go one by one. So first, when you record data, you have one folder. If you not make a one folder which you can access, where is your folder, and like that I have prepared my name, and then MATLAB, then I go to my name, and then whatever I need I can go to this. So today is just kind of test, so I have few readings here, and then I'll go to that folder. If it's not visible, you can see this is a little minimized, so like figure 1 I can make it add to selected folder and folder, but this will come later. First we have to treat the data. So this is the 4 reading I took just for experiment. So 2 is for EGFR before ligand activation, and 2 reading for after EGFR ligand activation. So we have only 4 reading. So what I have to do here, I have to get the path, because this is I already took. So, or you can see this is the path name, or if you have new file, you go here, copy this one, okay, and then put it here, paste it. So you have now opened this one, and you should be in that folder. So I will go here and click it, and it will say, and then I will enter. It will start running. So you can see one extra file is open here, and okay, so it's done because I have only 4 reading, so it's very quick. Then you see here there is one extra folder generated by mat out. So we have to go here and go add to path, selected folder and subfolder both, click here, and it's now light. So you go double click here, and now we are in the inside the mat out folder. You can see here as well. So we go to now second script. In second script there is a 2 placed, we have to change the path. Okay, so you can click here, copy the path and paste in here. So main path, and then another one is path name out. So this is in, this out. So go here and paste it here, whatever folder you working on the same day, or whatever name of the folder. Okay, so you paste both places. Now you click here, run it, new folder will open, then enter, and so you see here in this command window is asking yes one. So one more time enter, and this will, would you like to divide the any SAQ into the small SAQs? Yes, we need this one. So we one more time enter, and then that folder will open wherever our data is there. So you see this path length here, the same mat out. Then we have to select all folder. Either you can select by Control A or by visually. So I have only 4 readings, so I will collect and then open. Then it will going to ask you the time length of the. So we use around 10 because this is membrane protein, so we use 10 microseconds. So enter one more time, then it say enter bin size microsecond 10. So for membrane protein like EGFR or FA2 we use 10 microsecond, but in case of 3D standard like a liquid solution we use 1 microsecond. So enter, Then there's a two window will open here. One is this small one and one bigger one. So because this is only 4 readings, so it will be very quick. So once it's done, the smaller window will close and then you cut this one. Now, so you see from 4 to there's so many files generated, and then you have to go to next. So this is the next step. Like all 3 core, we have to run all 3 at same time, because this is for green color. We record our data in 2 color. One is green, one is red, and one is combined. So cross correlation. So here we have 3 files. So what we do, I'll take the path name from here, and there's 2 different places here. You can see. So I'll paste here my path, and I have to do this on all 3 codes. Okay, and then the third one as well. Now, so I change the name of folder. So in case of you doing some different dates, you have to just copy the path name. Okay, then I will open 3 different files, because this code is written that such way that you have to run 3 files at the same time. So I will open 2 more files. So now this is open. Okay, so the first file I will keep in G1, so H core G, and then second file I'll go in H core R, and then third file I'll go to H core X. So now all 3 open, and then I'll go first one G, make sure run here. So when I click run, it will say here in command window. Then I have to enter. The new window open, then enter. Another window open, enter. So 2 times enter you have to press, and then you can see it start here. And go to the second window, second MATLAB file, and then click here. Make sure this is in R. So click here, and then I will press enter, and one more time enter, one more time. So 2 times enter you have to press. Then I'll go to the third, and here X1. So click here, and then enter, enter, enter. So you have to press 3 times enter, and all 3 you have to press until this start. So this you can see here, it's just running now. So I can check all 3 files running. It may take around 2 minutes because I have 4 reading. But when you're going to treat big data like 40 reading, or for one data point or one experiment, for one experiment we use around 80 to 100 cells, and right now I'm using only 4 different cells. So it may take around maximum 2 minutes, but if you have 100 cells, it may take couple of hours. So once it's done, we can see here it will stop automatic, and that all this data going in this MATLAB folder. Taking some time, so that time I will show you how we record data. So this is this kind of cells we see in microscope first, then we focus our laser point on the periphery of the cells where not much cluster is there. So these are the COS7 cells expressing the EGFR gene with this is GFP and this is MCD, and this is combined overlap of both. So when you choose cell to collect data, both cells should be in the same range of fluorescence. So then both receptor, same receptor with the both colors should be in equal brightness. You see here, I give only 2 examples here. Let's go back to the folder. Okay, it's still running. I'll make another video where I'll explain how we collect data, how we focus on that on the scope. But today, just focus on how this MATLAB script we use for data extraction or data treatment. So once you have so many data points like 100 or 50, then we leave it and we can do some other work in that time. taking some time. Usually for full reading it take around 2 minutes, 2 to 3 minutes. Yeah, it's done. So you can see, I can see all here. Oh, it's still this one. Since I started Z first, so that's why it may be in a couple of seconds, I guess, because we have to let it finish complete all three. Yeah, it's done. So once it's done, then I can close two windows. And now we're going to, so we already use G1, R and X1. So I'll go now color choice. So color choice here, we record the data for 60 seconds, and I divide it in 6 different sets, so 10 seconds each. So for that, you can see here, this is the code we have. You see here, we divided the 60 seconds to the 6 different slots. So we see the 6 different graph of that. I'll show you that soon. So this is the file path name, file root, and so I know which one. So I'll go here, select this one, and rename, because directory won't let me copy in MATLAB. So copy, and then I can put this name here and paste, and then you have to remove this backside A. So we have to go here till CO1, so cell number 1, and then cell number 1, either you can press the F5 key or the start run. So I'll press the F5 key, then I'll see it will generate 4 different graphs. So see, this is the average of all 3, and this is the cross correlation of both for like GFP and MCD. This is autocorrelation of channel B and autocorrelation of channel A. And then we have to see if something is bad here out of 6. So you can see here, this is 1, which is out of shape here, 1 and 2, you can see here. So we'll see which color is that. This is 1. Okay, so if you want to make your data clean and this then you can remove this. This is your choice, personal choice, which one you want to remove. So I feel like this is out of place in that. So what I'll do, I'll remove this one. So you have here, I'll double click here, and then backspace or delete, and then run again. And yeah, I can see one more. I feel like I should remove this. I don't need that one. So this is 4th now, and run again. Now my data look pretty clean. So you have to bother about only this autocorrelation both. This is cross correlation, so don't worry about that. And this is the average of, then you will see all this 4, how it's going to make it. Once you know that this look good, and then you go here, Control G, you have to bring all 6 units again, and then change parameter here, like 1 to 2, cell number 2, and again press F5 key. Oh, so here this is 2 really looking bad. So one is 2 number, another one is 4 number. So I'll remove this one, 2 number and 4 number, and then F5. Now I see it's look smooth, all 4 remaining 4. So we can go with that, and Control G will bring all 6 points back. And here, because I took only 2 reading for 1 sample, so I'll go with another name. So what we have another with after ligand addition. So select this one, rename, and then copy, and I can paste this name here, and go back to C1 only, cell number 1, and then F5. So you see here, mostly look okay, but only the one I can see here, which is 0, is looking out of shape something. So I'll remove this one, and then F5 again. Now all looking, they are going a little bit, but mostly looking in the same way. So the profile, diffusion profile looking pretty good here. And and then I'll go here Control G, so my all 6 point will come back, and then I'll change here cell number 2, and then F5. So I see here 2 of them is looking out of shape. One is 0, another is 5. So I'll remove this one, 0 and 5, and then F5. So now looking okay. I mean, if you want, you can remove this one too as well, but they are looking okay for me, I guess now. Because we don't want to remove more than half, so it's not a good idea to remove. Or maybe I think I should remove the, this is now 3 number. Let me try to remove, see how. But this is your judgment. I mean, go with the best part will look. So now it's look much smoother, and then, you know, not out of place. So we can, so we have only two reading. I took only two readings, so I will go with that. And now once I'm done with here, so because I have only 4 reading and I already select 4, next we use this diffusion 2D, because this protein are 2D diffusion. So I gave here the name, because this is the name you can give, or you don't have to give. You are in the same folder, so don't worry about that. And but you have to make sure that, because we are running 2 color here, so you can see this is a plot RD for red, like cherry, and then GD for the green, and then XD for the both cross correlations. So we want to generate this auto correlation of each color and then cross correlation of both color. And if in case if you want only one color, you can put here 0. That's what is written in, you know. If you want to only generate the green color, then you put 0 here and 0 XI in front of XG. Only red RD and RF should be 1 1. Or if you want the green color, then put 0 in front of R. But right now I'm using both color, and so cross correlation. So now I'm in same folder, so everything is correct here. Or if you want to make some change some parameter, like, you know, I'll go back a little bit here. In case of red, green or something, then you can change the tau value or t value or other part. But in our case, mostly we use the same parameter for all the data treatment. So here, then I will press this run. So it will generate the graphs, what I choose here. So since I have 4 readings, so it will generate at least 4 graphs. Okay, so once it's done, we can see here, it is stop working here. So I can close, and then I'll go here. So here we have 2 data, I mean, there's a couple of different reading states here, but we are just interested in, you know, title number, what the title number of that sample, and the Excel sheet for Excel. So here we have title number. Just double click here, so open here. So I will take before ligand activation, so this is easier, copy, and then we make, so I have make, we have, you know, one parameter set for this file. So okay, so I made today's Excel sheet. So Excel sheet we have, this is, let me open, so this is, we have already set this Excel sheet parameter here. So if you have old Excel sheet, you can just delete old readings and just left 2, because this is, you know, standard deviation, so we need 2 at least from old, but I'm going to replace that one with the new data point. Okay, so I will choose the first one and then paste it here, the new data point, whatever I got it. So this is file name, and then I'll take the Excel sheet for 2, initial 2, copy, and go to the Excel sheet, and then paste it here. So these are the parameter we got it from here. Okay, then you, since I have 2 reading only, you can go more than whatever you want. So just then drag this parameter, you have to drag, so it will give you the, in my case, not showing anything because I already prepared this one. But if you have new reading, it will show you everything change. Okay, then we'll go to HBGF. Because so what we do here, we have to make different name. If you have 10 samples, you make, you know, this is EGFR without ligand and with ligand. So without ligand I took 2 reading. Usually I take 80 to 100 reading, but this is just for video purpose. I'm just showing you 2 reading, because it will, or else it will take a lot of time to treat data. So HBGF. So we go to MATLAB again, and take the name of that sample name. So this is the I record to sample name, and then we paste it here. Though I have same name, that I tried this before making this video, and then go here, Excel, then take the same this related to that sample and paste it here. So when you if you have different reading, it will show you the different value, but this is same value, so not showing. And then you have to drag this sample, so it will give you the exactly what is a parameter. So by this process, what we get here, these are the parameter we got, the population density of red and green and both, and the dwell time, how long it take to traveling in that optical volume, and the triplet state. But what we interested here in getting the FC value, what is the cross correlation between the receptor, and then the brightness of the fluorophore, are they good or not. We need at least 100 value, but it's pretty good here, you can see. And then how fast they are moving. So this is DR, diffusion of red color like M cherry, diffusion of green color like GFP, and diffusion of both, like when they make cross correlation. So you see here, because EGFR mostly won't make a dimer, so you see value is 002, which is pretty low. But if they make dimer, then its value should be around 0.07 to 0.15 also. So when we add, and this is the density, how many EGFR or EGFR tagged fluorophore molecule there in that. So this is the R, like red color, and that's green color, and this is the combined both color. And when we see activate the EGFR with ligand, and we all know that ligand activate make the dimer formation. So you see here the FC value is increased to 0.27 or 0.0. Sorry, no, this is average. This is 0.32 or 0.219, which is kind of, this is making dimer, or this is trimer. So that's what we get value. So we are interested in that, and we want to make sure that brightness should be more than 100, as I said earlier. But here it's pretty good, because you see the expression of cells is pretty good here, and they are kind of same range. So these parameter we want to know it first. Once we have this parameter, either you can I'm just showing you 2 value here, but usually we record 80 to 100 cells. So once we have this parameter here, you can use MATLAB to generate graph. So I will cut this one graph for you, depend on how many parameters. So this is another script in our lab. So we use different parameters. What you want, you can get all the parameter here if you want. We got, if you see this value here, you have all the parameter here. This one here. I can make graph of all, but we are not interested in that. So mostly what we generate a graph with the FC value, what the cross correlation between them. And so I'll give the 16 FC value, and then the brightness of both receptor, how much fluorophore, and then the diffusion of, so as you see, like this one, you see here. So I'm going to make the graph with this one, here to here, because this is what important stuff we want to extract from that. So I have here this script. So if you see here, I have 2 point here. One is EGFR wild type, but then ligand activation. So same thing I'll give here. So if you have many names, like 10 different, because EGFR have 7 ligand. If you have 7 ligand, you can put this all 7 ligand here, but you have to separate with the comma. Then this is the part to go. So this is where my figure going to go. You can make according to you, whatever, wherever you want to put them. Okay, and this is the Excel sheet location. So my Excel sheet in that folder. If you see here, this in that folder. So you see here PC, and then so that's what I gave here, name Excel, E track MATLAB, and my name, and then test, and then so Excel sheet there. So Excel, so you can change that. So same thing here, ticket name. So the EGFR wild type and ligand activation. Once you have this parameter, you don't have to change much here. Just give the name, because I already give this name, so I'm not remembering, or else you can copy from here and give the name direction wherever you want to put this figure. Once you have here, then you can, so this is another X box plot, and click here. Once you click here, it will generate figure based on whatever parameter you want. and these figure will be saved in your folder, the path name I gave. So I'll show you that one. You can choose less if you want. So some people just take only the FC value and diffusion only, but I just took from 16 to 24, and whatever you want you can just change here, 16 to 24. So let me go to the folder. So we have figure here, right? Figure folder, so this is generated, and we have all the figures here. So look at the FC value here. We have FC value. So FC value of EGFR is 0, which not make it is kind of monomer, but FC value of after ligand activation is 0.23, which make it kind of trimer. We'll close this one. So these figure you can use for, what is the, so just I can take this figure, copy, and then make sure you want to put it here, what the FC value of your experiment. Or one more thing, you want to paste it here, you can go to test here. So when we treat this data, we MATLAB generate, and that's where we can find the graph. So what the graph of before and after. So this is EGFR graph which is generated by. So EGFR not making timer is monomer, so you see the blue curve is on the bottom. So I can copy this one from here just to present somewhere data whenever I want to present, and then go back to here. So I can take one graph from after ligand activation. So I'll take this one, copy, and paste here. So we have two graph here. I can make smaller this one, or maybe you can make bigger, and you can show wherever you want to show your data. So this is before ligand activation, this is after ligand activation, and then you see we have figure, and then how this graph look like, and then the FC value. Or if you want to show the diffusion fast or slow, you can prepare in that way. Okay, let me know if you have any question in comment section. Thank you very much for listening.